Good morning, my dear students of class 8. We were studying chapter 5, language of chemistry. Here we had studied symbols, valency, variable valency, then radicals, then how we can write a chemical formula, then what are the importance of a chemical formula or molecular formula, then what is chemical equation, how we can write a chemical equation, what are the steps for writing a chemical equation. Today we will start a new topic, law of conservation of mass. What is law of conservation of mass? We should know this definition, that law of conservation of mass, it says us that the matters can neither be created nor be destroyed. During a chemical reactions, matter can neither be created nor destroyed. It can be changed from, transformed means it can be changed from one form to another. So matter can neither be created nor destroyed. My dear students, we know that during a chemical reaction, this one is called reactant, and whatsoever is formed is called product. So total mass of this reactant and total mass of this product should be same. Neither it will increase, the mass of product will neither increase nor decrease. If the mass of reactants and products are same, then only say that this reaction follows the rule of law of conservation of mass. For example, we know that hydrogen combines with oxygen. It forms water. Molecular formula of hydrogen is H2 and molecular formula of oxygen is O2, and the molecular formula of water is H2O. This H2 is here 1 into 2. Atomic mass of hydrogen is 1. So here are 2 atoms of hydrogen. So mass will be 1 into 2 plus. Here are 2 atoms of oxygen. So 2 into atomic mass means mass of one atom is 16. It will be 2 plus 32. It becomes 34 AMU. Now if we take it in terms of gram, means 34 gram of reactants is taking part in the chemical reaction. Out of 34 grams, 2 gram is your hydrogen and 32 gram is your oxygen. Now come to product side. Here it is hydrogen plus oxygen. So 2 atoms of hydrogen plus 1 atom of oxygen. So what will be mass? 2 into 1 plus 1 into 16. It will be 2 plus 16. 18 gram of water is produced. If it follows the law of conservation of mass, here we can observe 2 things. First is what? 1 atom of oxygen is lost. Here are two atoms of hydrogen. Here are two atoms of hydrogen. Here are two atoms of oxygen. Here is only one atom of oxygen. That means there is a loss of one atom of oxygen. Obviously, there is a loss of one atom of oxygen, but it does not happen. There will be no loss of atoms. Atoms can neither be created. We know, right, it from class 7. Atoms can neither be created nor destroyed. What thing we observed? One more thing we observed. The reactant's mass was 34 gram, while the mass of product is 18 grams. So 34 minus 18, 16 gram of mass of reactant side is lost. Obviously 16 gram is lost. It also does not happen. Both the observations are not applicable, because for this loss of one atom of oxygen, we know atoms can neither be created nor destroyed. For this, just right now we had seen that mass can neither be created nor destroyed. Mass can neither be created nor destroyed. We had seen in our previous class there are two types of equations. One is your unbalanced equation, what we call it skeleton equation, and another one is balanced equation. What is skeleton equation? If you see here, there are two atoms of hydrogen. There are two atoms of hydrogen. So number of hydrogen atoms on reactant side as well as product side are same, but the number of oxygen on reactant side is 2, while the number of oxygen on product side is 1. So this is a skeleton equation. To balance it, now here there are two oxygen atoms. If we multiply it, there will be two oxygen. Now it becomes 4 hydrogen atoms. So we multiply hydrogen by 2. So now here are 2 hydrogen. Here 4 hydrogen. Here also 4 hydrogen atoms. Here 2 oxygen atoms. Here will be 2 oxygen atoms. My dear students, these two multiply the whole. Now this is your balanced equation. So now if the equation is balanced, then see what happens. Here are 2 into 2 hydrogen. In fact 4 hydrogen atoms. Here one molecule is here. Here are 2 atoms of oxygen. First see about the reactant side. So 2 into 2 means 4. Atomic mass of hydrogen is 1. It will be 4. Atomic mass of oxygen is 16. Then it will be 2 into 16, 32. Then 32 plus 4, it will be 36 AMU. Now if we express in gram, it will be 36 gram of reactant. For the product side, see, this 2 is multiplying the whole. So here is 2 atoms of hydrogen plus 1 atom of oxygen. Then it will be 2 into 1. Atomic mass of hydrogen is 1 plus atomic mass oxygen is 16. It will be 2 into 1 plus 1 into 16 will be 2 into 2 plus 16, which comes 36 gram. Now if you count the number, here are 4 atoms of hydrogen, here are 4 atoms of hydrogen, here are 2 atoms of oxygen, here are 2 atoms of oxygen. So in the balance equation, number of each atoms are same on both reactant and product side. Number 2, on the reactant side, the mass of reactant is 36 gram, while the mass of product is also 36 gram. Means mass, there is no change in the mass of reactants and product. There is neither loss or gain. So a balance equation satisfy both the things. The number of atoms will be same on reactant and product side, and the total mass of the reactant will be same as the product side. So now what is the need of balancing a equation? I have told you a balance equation says both these things. What both these things means, it satisfies both the things. There will be no loss of the atoms, means number of atoms. A balance equation says number of atoms on reactant side is equal to number of atoms on the product side. First thing. Second, total mass on reactant side is equal to total mass on product side. It remains always the same. So a chemical equation needs to be balanced to make the number of atoms of the reactants equal to the number of atoms of the products. This is because to chemical reaction it is just a rearrangement of atoms. Atoms are neither created and nor destroyed during a chemical reaction. Therefore, balanced equation for the reaction will be this. So a balanced chemical reaction is the reaction, it is the symbolic representation in which the number of atoms of each element on the reactant side and on the product sides are equal. I had given you the example of formation of water. Here we will see the example of calcium. When burnt it forms calcium oxide. Now what are the significance of a balanced chemical equations? A balanced chemical equation is a wonderful way of representing a lot of information. What information do we get? So first it shows which substances are taking part in a chemical reaction and what product are formed. Here we had seen that hydrogen and oxygen are taking part in the chemical reaction and this water is formed. Here it has taken calcium and oxygen are the reactants and calcium oxide is formed. Then it shows both the numbers of molecules and number of atoms evolved or taking part in the chemical reaction. Here it is saying that 2 calcium atom plus 1 molecule of oxygen, and 1 molecule of oxygen contains 2 atoms. It is forming 2 molecules of calcium oxide. It makes us able to calculate the actual amount of the reactants. We had seen in the case of this how we can calculate the mass of reactants, how we can calculate the mass of product. So it makes us enables means it makes us able to calculate the actual amount of reactants and actual amount of mass of product side which is formed. Since we are calculating the mass, we are calculating the quantity, therefore it is also called quantitative analysis. Now it makes the study of chemistry easy and systematic. Here are the chemical equation. This is the chemical reaction which is represented by reaction represented by symbolic representation. So now this is a chemical reactions which is shown by the symbolic representation, means in the form of chemical equation. This chemical equation now represents about the chemical reaction. When calcium is burnt, it forms calcium oxide. So calcium reacts with oxygen to form calcium oxide. Calcium reacts with oxygen to form calcium oxide. Two monoatomic molecules, atomic molecule of calcium combined with one diatomic means oxygen, it forms. Here are the explanation. So this is for today. We will start the new topic, how to balance a chemical equation. We will proceed this topic in our next class. See you. Wish you all the best. Once again, I would like to remind you that on 1st and 2nd there is a mock test for one paper, and from 17th of August you will have your first terminal exam. So study well. See you all the best. Bye bye.